Okay, thank you everyone for dialing in and welcome to this British Hydrological Society hosted lunchtime webinar. This is the second in our mini-series of webinars about updates to the FEH statistical method. Last week we learnt about how the catchment descriptors are changing and some of the rationale and methods behind that. This week, we're going to learn about what that means in terms of implementing the statistical method and how it's going to be used in the future. We've got speakers from the UKCEH and from Wallingford HydroSolutions speaking today. And on the BHS side, we've got myself, Will Rust, and Kirsty Murphy. Will both be keeping the show on the road as we go along. Pressing, there we go. Okay, so some quick housekeeping rules. This will be recorded and it will be going onto our YouTube channel afterwards. Please make sure your microphone and your video is switched off. We will be having a Q&A session at the end, so if you do have a question throughout or at the Q&A session, please pop it into the chat box and we'll be going through and relaying those to the speakers and getting their answers at the end of the presentation. Okay, a quick slide on the BHS itself. So if you aren't aware, the British Hydrological Society is a members-led society encouraging interest, scholarship and good practice in scientific and applied aspects of hydrology. And we seek to foster involvement in national and international hydrology as well. So what do? We organise webinars and in-person events and conferences, webinars such as this. We also provide funding and training grants for conferences and even in partnership with JBA scholarships, studentships, for master's tuition fees. We also have a quarterly magazine with all sorts of updates and information on what's happening in the UK and international hydrology news. So if you want to stay up to date, I would highly recommend becoming a member if you're not already. There is a reduced fee for early careers and retired members as well. So one of the things you have the opportunity to do as a member is actually to get involved and help shape the BHS. I mentioned last week that we are soon to be holding nominations for elected committee members. That email has actually gone out to members. I believe it went out on Friday. So if you are interested in shaping the BHS, the subcommittees that you have available to get involved with are the education and careers, communication and publications, meetings and events, and finances. So if any of those take your fancy, do have a look at that email that came around and get in touch with us if you are interested. And finally, a plug for some upcoming events. The Peter Wolf Symposium is happening at the end of this month. There are unfortunately no more tickets left for that, but that is a yearly early careers conference. So if you have the opportunity to go next year, do keep an eye out for that. It will be running next year as well. If you are interested in learning about what the future of hydrology is going to be like and how we're going to be undertaking hydrology different in the future, then do sign up for the AGM and webinar where we're going to learn about updates on the flood hydrology roadmap for the UK. So tickets, that's on the 16th of September. So if you're interested, do stick in save the dates in your diary. Tickets will be out for that soon as well. And then finally, we've got an in-person conference co-hosted with the Royal Meteorological Society on forecasting flash flooding. It's been in the news an awful lot lately. It's going to be a really interdisciplinary conference. We're going to learn a lot from the meteorologists, and hopefully the meteorologists are going to learn a lot from us hydrologists as well. So keep your eye out for tickets for that. That's going to be advertised soon through the usual social media and the mailing list as well. So that is it from me, actually. I will stop sharing my screen now and I will hand over to Adam, who's going to introduce the presentation and the speakers.
Yep, thanks, Will. Let me just take over that. There we go. Okay, so yep, I'm going to be speaking today about updates to the FEH statistical method. So there's going to be me and Gianni talking from UKCEH, Tracy Haxton from Wallingford HydroSolutions, and then we've got Claire Waller from the Environment Agency, Owen Shepherd from Natural Resources Wales, and Becky Wilson from the Scottish Environment Protection Agency, who are going to be offering some guidance slides towards the end of the talk. Just for kind of completeness, I'm sure lots of you saw this last week, but for those who didn't, the FEH methods date back as far as at least 1975 with the Flood Studies report, and then the Flood Estimation Handbook itself was published in 1999. And since then, we've had smaller updates to aspects of that. There's been updates to the rainfall runoff models in between, such as updates all the way up to FEH 22. But the last major update to the statistical method was in 2008, 2009, which is the green report done via DEFRA. And then since then, there's been a minor update from for BFI Hose 19. So what are the FEH methods? We have, the FEH methods are a way of estimating flood return periods or flood return levels. So how large is the 1 in 20 years flood, or how big do so we've got, if you've got lots of data at your gauge station, you can use annual maxima or POT data and the generalized logistic distribution to estimate those return periods directly. Obviously, if you have short records, poor records, or in fact no records, you can't do this. In order to model these at on-gauge locations, we have the FEH method. So we have the QMED equation, which we use to estimate the 2-year flood, which uses catchment descriptors, such as those we discussed last week, and we'll recap those briefly as we go along. And so this gives us a local estimate of the 2-year flood. There are some spatial model errors in this QMED equation. So a donor transfer method uses the nearest good quality stations, stations that are flagged as suitable for QMED, according to the NRFA, to correct for those spatial model errors. And then for the rarer floods, we use a regional flood frequency method called the pooling group method to make use of more AMAX data, which uses hydrologically similar good quality catchments, so suitable for pooling, to estimate a growth curve where we assume that hydrologically similar catchments act similarly in rare return periods, and then you scale that by the QMED to get your final flood frequency estimate. These models assume your catchments are as rural. And so in order to account for the difference urbanization makes due to surface runoff and interception, we have these urban adjustments which scale both QMED and the growth curves. So what's the update all about? We're going to be updating the QMED equation, the donor adjustment method, the urbanization adjustment, and the pooling method. And last week we spoke about the catchment descriptors that are going into it, but this week we're going to talk about the methods themselves. Overall, the methods are the same. Most of them have just been recalibrated using the new catchment descriptors, and any actual big changes, of which there's very few, will be highlighted as we go along. So why update? As I mentioned, there's been no major recalibration since 2008, except for the small catchments work. However, there's been almost a huge amount more AMAX data, so there's almost twice as much annual maximum data. And as we said before, with all the newer spatial data products, we've been able to develop new catchment descriptors. But models can be sensitive to the version of the data used, the period record, and exactly which catchment descriptors are being used. So it's not appropriate to just blindly plug in the new catchment descriptors into the old model without checking if we should recalibrate. And so these new catchment descriptors are much more geared around describing the present day, kind of status of a catchment. And although we're still working on some comprehensive non-stationary methods, an approach that describes the current day catchment is useful for all the forward-looking projects. So as I said, last week we spoke about SAR 1920, FAL 2015, which looks at attenuation due to reservoirs and lakes. We got an urbexed update to 2015, so that's urban extent, and a minor update to BFI host 19, which avoids double counting for lakes. As we said here, we've got an extra few gauges. We've got that the longest gauge is now 136 years long, and the mean record length is increased by nearly 40%, and the number of any maximum has increased by 44%. And obviously since the start of the High Flows UK peak flow dataset, we've got an extra 20 years worth of data that's suitable for rural and suitable for QMED estimation. And at this point, I'm going to hand over to Johnny to actually talk through the new methods.
Okay, thank you, Adam. So within the new methods, there's obviously the QMED equation, donor transfer, pooling, and urbanization procedures for both QMED and pooling. So the first thing we'll talk about is the QMED equation. Thank you. So the number of gauges that was used to calibrate this, as you saw on the last slide, is slightly increased. A lot more importantly, the average record length is increased from about 33 to 45 years, which reduces the sampling variability in the estimates of QMED that we're fitting to. QMED equation itself is fitted using a maximum likelihood function of the same form as was published in the 2008 report. This function is useful because it accounts for both sampling error in the gauged QMED estimates and the correlations of the QMED estimates. The relationships of these were both recalibrated during the process of recalibrating the QMED equation. The equation is below on the slide, and as you can see, the overall form of it is the same. So area, SAR, file, and BFI host, where the SAR, file, and BFI host descriptors are updated. We did try different transformations of these descriptors, and we did do stepwise regressions to try out different descriptors. But the form that we had in 2008, that's slightly updated here, was the best that we could do before hitting like serious diminishing returns. The R squared of this equation is 0.948, which is a slight improvement over the existing older equation. The FSE is 1.431, which is the same as the existing equation. If you go to a fourth decimal place, it's slightly improved FSE, but it's very marginal. Next slide, please. So comparing the 2025 and the 2008 equations, a lot of the values are very similar. So out of the 626 catchments that we used in the calibration, the new QMED equation is mean 1.3% higher value than the 2008 values. The median is decreased by 0.4%. And then the middle 323 of the 626 catchments show a decrease or increase of around 7% or less. Next slide, please. So following on from the QMED equation and recalibrated at the same time as part of the maximum likelihood function was the donor adjustment procedure. This is completely necessary because the way the QMED equation is calibrated, it forces the errors, so the difference between the gauge and the estimated QMED, into a spatial pattern, which you can see Adam circling with the mouse. And so donor transfer works by finding the error at a nearby site, which is statistically likely to be similar to the error at your site, and then copying that error onto your estimate in order to remove that error from your estimate. You can also see the patterns are not perfectly smooth, and that's the reason for taking an average of multiple donors. In the new method, we increase the number of donors that you should use from 6 up to 8. At this level, the R squared stopped increasing and the factorial standard error of the estimate stopped decreasing. So after going from not using donor transfer to using donor transfer, the R squared of the new QMED estimates has increased to 0.96, and the factorial standard error is reduced to 1.373. Next slide, please. One thing that's very important to point out with the donor transfer is, as I said on the last slide, the errors in the QMED equation are spatially distributed, and it's the error that you're looking to correct the donor transfer. You can see here that the model errors are not related to the catchment descriptors. So if you exclude a donor because it's too different in one of the catchment descriptors, that doesn't help you to remove the model error from your QMED estimate, so don't do it. For example, if you look, say, like on the log area plot, if your catchment has a log area of 4, which is around 50 square kilometers, if you want to exclude catchments that are too large or too small, the values that you're left with have a similar distribution of model errors centered around 0 to all of the catchments. Next slide, please. So the urban adjustment for QMED should be applied to all catchments regardless of their urbanization level. That's to avoid any discontinuities if the urbanization suddenly jumps from below a threshold value to above a threshold value. This uses the same form of the equation as we had before. It's just now been recalibrated to use URBEX 2015 instead of URBEX 2000 and to use BFI host 19 scaled instead of BFI host 19. The way the fitting works is a lot like the original urban adjustment. This can give very large values when urbanization becomes very high or BFI host becomes very high. So if you get a value that's above 10 times, you should cap it at 10 times. Next slide, please. So the summary of the QMED equation, donor transfer and urbanization is shown on the maps for 884 catchments. This is all of the NRFA data set that we use to calibrate the method, excluding catchments that are FEH suitable for neither. You can see that the differences between 2008 method and the 2025 method are generally very small and distributed without much of a spatial pattern. You can also see from the left, which only plots the approximately 50 or so sites where QMED is increased by more than 25% and the 8 sites where QMED is decreased by more than 25%. So 59 sites out of the 884. You can see the reasons for these changes. So many of the catchments where QMED has been increased by more than 25% is because either SAR and or URBEX 2000, well, URBEX SAR to SAR 9120 has increased, or URBEX 2000 to URBEX 2015 has increased. There's also some catchments where reductions in BFI host have resulted in an increase in QMED. 4 of the 8 catchments where QMED has decreased from 2008 to 2025 are because the value of FAL has decreased. And then with the other 4 catchments, some further research into that shows that these changes happened as a result of donor transfer. But bear in mind, this is showing the difference from the old to the new method, not the error between the new method and the gauged value. In actual fact, these 4 catchments where QMED has decreased, 2 of them actually bring it closer to the gauged value. 2 of them push it further away from the gauged value. And that really shows that the QMED method itself is slightly improved, but not massively improved, which is what we showed on the first slide. Also important not to focus too much on just 2 catchments out of almost 900. There's a strong on average improvement. It also does show the importance of checking the descriptors that you put into the equation, because the equation is only as good as the data that goes into it. Next slide. So the new pooling approach, similarly to the old one, it has log area, it has floodplain extent, it has FAL. The transformation on FAL has been changed to FAL squared. it has SAR, the transformation of which has been changed to 1000 over SAR, similarly to the QMED equation. And it adds a fifth descriptor, which is 1 over BFI host. Three of these descriptors are three of the descriptors that were updated this year. This was calibrated using the same sort of methods as the 2008 approach, so using the pooled uncertainty measure, minimizing it. The descriptors themselves were selected via a stepwise regression. One big change from this similarity distance measure from the last one to this one is that there's a more equal weight between area and SAR. And because of this, we now only recommend using this one similarity distance measure for all different sizes of catchments. We tested this and it outperformed the small catchment similarity distance measure for small catchments. One other change is that we've reweighted or recalibrated the weighting of individual catchments within the pooling group. And this means that there's no, if you like, enhancement for at-site data. The at-site data is still weighted highly because the weighting is based on similarity, and the similarity between, if you like, the at-site data and the site of interest is, well, it's exactly the same. But there is no extra enhancement to the weighting anymore. Next slide. So you can see that the changes comparing 2008 to 2025, the 100-year growth factor, the changes in this are small and they're distributed fairly evenly across the country. This is considering only the rural sites that are suitable for pooling at the moment. There's potential clusters in the northeast and southwest of England, but this is a lot more complex with a lot more interacting factors than QMED. So the reasons for this are mixed. You can't really assign it to one descriptor or another. Next slide, please. And so now for urban adjustments in pool estimates, if you just plot flood frequency curves for urban areas, they are usually visually flatter than rural ones. And that's the thinking behind adjusting the LCV and the L skew, so the L moments of the distributions. You can see in the plot comparing the at-site LCV against the pooled LCV, and then plotting this against the urbanization of the catchment. It starts at the two being roughly equal for no urbanization, and there's a gradual decrease as urbanization increases. So flatter flood frequency curves for more urban catchments as we'd expect. If you look at the L skew, there doesn't seem to be a pattern. So the skewness of the flood frequency curve is not affected by urbanization. So for this reason, the urbanization adjustments now only apply to the LCV. That was recalibrated again using Urbex 2015 rather than Urbex 2000, and it's a similar but not exactly the same adjustment. Next slide. So in summary, this map just shows the changes in the 100-year growth factor for all of the catchments in the calibration data set that are suitable for pooling. So that's urban and rural, with the urbanization adjustments applied to all catchments, whether they're urban or rural, although obviously the adjustments are very small for the rural catchments. As you can see from the plot on the left, showing catchments where the growth factor is changed by 25% or more, either up or down. That's only 28 catchments out of the 530. You can see that the reasons for this are varied, and it can't really be assigned to one descriptor or another, but a mix of them. Next slide, please. And then this final slide here just shows the combined effect of the new QMED equation, donor transfer, urbanization, pooling, and urban adjustments to the flood frequency curve for the 30-year flood peak and the 100-year flood peak. And this shows that the small increases in the QMED on average and the small decreases in the flood frequency curves on average tend to cancel out when you actually use them to look for a two-year flood peak, because most changes here are now small, spatially distributed. Some of the larger increases are in the southwest of England, and there are also smaller increases around peri-urban areas, which are due to increases in urbanisation. That's just a quick summary of the results of applying everything there. Next slide, please. Thank you. Adam, are you doing this, or is this me?
Yeah, thank you, Johnny. I'm going to carry on and move on to the how we think people should be applying this. So just a few quick slides on how UKCEH recommends making use of the methods. As we mentioned last week, if you're using the new method, make sure you're using the new catchment descriptors. Don't mix methods and catchment descriptors unless there's a strong reasoning behind why you're doing it. If there's sufficient gauge AMAX and POT data, then use the gauge AMAX and POT data. Always use the donor adjustment and the urban adjustment if you're using the QMED equation. This is mostly going to be repeating what Johnny said, but I think it's worth pointing out in one go. Don't discount donors on catchment descriptor values or record length, although do check for factors that might make either the gauge equation, the gauge estimate, or the QMED equation unreliable. So check for data quality, check for unique catchment properties or behavior, for example, unusual groundwater effects. Note that the new pooling method includes BFI host 19 scaled. So in the past, some pooling groups have had members with high BFI rejected. We don't suggest you do that anymore if you're using the new method. But always check your pooling groups for homogeneity, data quality issues, very high urbanization, all the standard things you've been doing already. But we do recommend you apply urban adjustments to all pooled estimates, even if it's only very slightly urbanized. Applying this kind of urban adjustment consistently across all estimates will mean you don't have any weird jumps when moving from rural to urban areas. And use these equations for catchments of all sizes rather than a separate model for small catchments. And as Tracy's going to mention in a bit, most of these methods are going to be in WinFAP 5.3. And just some overall general recommendations, which is the old FEH local kind of paradigm, which is start with local knowledge. If something looks odd, don't just blindly use it. See if local knowledge gives a better value. Check nearby catchments, check historical records. If you need to, when you have the resources, try taking new measurements. And note that these national scale models assume nothing about local data quality and are the best on average under this assumption. So there may be areas in the country or specific sites where these models don't perform as well. Always check your data, always check your donors, and always check your pooling groups when you're doing this sort of thing. We're still using the same uncertainty quantifications before. On the FEH web service, there is a document, and I think on the FEH website themselves, there is a uncertainty document describing the different types of uncertainty quantification available in WinFAP and through the FEH statistical method. As Johnny mentioned, the changes in the results are due to lots of different things. So new data, new descriptors, new methods, and only some of those are changes in the catchment over time. A big change does not always mean an error in the new method. It might mean that the catchment actually has changed between the two sets of catchment descriptors. But if you've got those big changes, then it's definitely worth a check. So all the new data will be in NRFA Peakflow version 14. So you can see last week's YouTube video or to get a recap on that and all that. So all that data is going to be on the NRFA website. Have all the new data and all the new descriptors you need to do that. So I'm going to hand over to Tracy, who's going to talk a bit about WinFAP.
Hi, yes, so I'm just going to talk about implementation of the new method in WinFAP. So first, you will still be able to use, so obviously the NRFA Peakflow dataset version 14 is coming out at the end of August. And just to say that WinFAP 5.2 will still be compatible with that, even though it's got these new descriptors in there. WinFAP 5.3, which will contain these new methods, will come out in early September. And in that, you'll be able to use the sort of the 2008 method or the 2025 method. So we're calling this updated method the 2025 method because the main methods, which were in 5.2, date from 2008, even though they incorporate other updates, we're calling that the 2008 method. And sort of it will all be backwards compatible, so you'll be able to import 5.2 project files into 5.3 as well. Next slide. Thank you. So just to say, the updates in WinFAP 5.3 are you can use either the 2008 or 2025 method. There's a slight update to the urban extents for the 2025 method, and you'll also be able to use non-flood years for the 2025 method as well. Have the next slide, please. So the method is, so in terms of practicality of how you actually do it, when you do a pooled estimate and you sort of right click to get this window up, that's where you'll make the decision over which method you'll be using. So here, by default, it'll say to use the 2025 method. You can opt to change the other. And as we can see, the pooling group size will change depending on what you've selected. Can we go to the next method? Sorry, next slide. Yeah, so in most of these windows, hopefully it'll be quite clear which method you've used. So it'll be really obvious. So not only will all the catchment descriptors be updated, so if you've got updated descriptors, you're definitely using 2025 method, but also throughout we'll try and flag up and put little reminders elsewhere over which method you're using so that you don't get confused over whether you're using the old method or the new method. Next slide, please. Yep, so there's a slight update to the urbanization. So as before, though, you can use the default method or you can use a user-defined method. So it works off the Urbex 2015 value. So what happens is you can put in either an Urbex based on an updated land cover map, for example. You can do an estimate of your urban proportion based on OS mapping, or you can put in a proportion based on the OS Open Built Up Extents proportion, which is a freely available data set. And from all of those, it will estimate the Urbex basically. So you can update it based on these sort of freely available data sets if you've noted that there's been increased urbanization in your catchment compared with the Urbex 2015 value. Next one, please. And lastly, we've also added the ability to use non-flood years as well. So particularly in these dry catchments, sometimes you get lots of non-flood years and you need to do the adjustment. At present, you have to do this externally to WinFAP. So what we've done is we've introduced it into WinFAP, and we've introduced it as effectively another distribution to try and keep it sort of fairly as sort of simple as possible. So it's called the sort of generalized logistic non-flood year. So because the non-flood year sort of methodology has only been developed for the generalized logistic distribution, we thought that would be the easiest way to incorporate it. There'll be an extra tab on in your pooling group window, so you'll have AM data, and then you'll also have AM data non-flood years. So that will give you your L moments for if you've done a non-flood year adjustment to it as well. And when you do your results, because it's effectively another distribution, you'll easily be able to see how much difference it's made by including those non-flood years. You'll be able to look at the sensitivity of doing that non-flood year adjustment for the generalized logistic distribution. So those are the main updates. Hopefully they'll be fairly easy to implement and will also sort of be clearly defined as you go through the software. So I think that's all I have to say on WinFAP.
Okay, thank you, Tracy. So I think first we're going to have Claire Waller from the Environment Agency to talk to recommendations for England.
Thanks, Adam. So hi, everyone. I'm Claire Waller. I'm a senior advisor in the National Flood Hydrology team at the Environment Agency. Our team is responsible for the Environment Agency's flood estimation guidelines, which are available at this web address. They were last updated in 2022. So over the last few months, we have completed a full review and update of these guidelines to include these new statistical methods and catchment descriptor updates, but also other updates such as FEH 22 rainfall. We are working towards getting these guidelines updated onto gov.uk by September. We are cautiously optimistic that this will happen, but if it is delayed for any reason, we will make the draft guidelines available on our external SharePoint site in the interim. We also have a standard report template and review templates for flood estimation calculations. We are updating those as well for the new descriptors and statistical method changes, and they will also be made available on our external SharePoint site from September. If you don't yet have access to our external SharePoint site, we will put a link to the form in the meeting chat. Please fill this form in, and within a few weeks, we will send you an email to say you've been added. And we do welcome comments on how we can improve our guidance and our templates. Please send them to this email address. Next slide, please. So in terms of transition timeframes to using the new methods, a few years ago, we set out some general guidance for transitioning to using new methods and data with a 6-month transition period generally applied. And this was what was used in the FEH 22 rainfall update in 2022. And we're going to apply the same principles again here. So for any new projects that begin after the updated methods and data are available, you should be using those latest methods and data. For projects that are already underway, if you submit those for review to us within 6 months after the new methods are available, for practicality reasons, we won't be asking you to update those calculations. Although if you want to, you can of course choose to update them, and the risk of still using those older methods lies with the project, not with us as reviewers. After 6 months, we would expect to see some consideration of whether the new methods will significantly change your project outcomes. And this could be in the form of a discussion where you explain why the update doesn't affect your particular study. So for example, if you're using different methods, if you're not using statistical methods at all, then there would be no impact on your study. Alternatively, you could include a sensitivity test at a key location to explore the potential impact. And if that change is significant for your project outcomes, then you should be updating your modelling. So as an example, many studies do use plus 20% peak flow as a sensitivity test to explore the impacts of uncertainties on your flood extents, and they factor that into the design as part of the freeboard. So if the change is less than 20% peak flow, then you may not need to do updated modelling. If it is more than 20% peak flow, then you may need to change your design, but you will need to determine what is significant for your own project and provide evidence to support that. If you are concerned about the possible impacts on your project, there are some steps you can take to try and future-proof it by using local data as far as possible. So the largest changes typically happen where people are relying on catchment descriptors alone. If you use local data, this is in line with the flood estimation handbook guidance that says you should use catchment descriptors as a last resort, and always use local data as far as possible. So check your catchment descriptors really carefully, look at the most up-to-date mapping and change your descriptors if they are no longer representative of your catchment. Use local flow gauges as far as possible to estimate QMED rather than relying on catchment descriptors alone. So do use donor transfer, and you can also use the QMED linking equation that someone asked about in the chat. Also, you can sensitivity test your project outcomes to a range of higher flows so that you understand beforehand how increasing flows could affect your flood extents and scheme design and where any critical thresholds might be. Next slide, please.
Yep, so I think we've got Becky Wilson from SEPA to go through for Scotland.
Hi, thanks, Adam. Hi, I'm Becky Wilson. I'm a senior scientist in the flood modelling team at SEPA. SEPA actually have 2 guidance documents that discuss flood estimation methods. The first is our technical flood risk guidance for stakeholders, which outlines SEPA's requirements for undertaking a flood risk assessment in Scotland, and it was last updated in 2022. Our second guidance document is the flood modelling guidance for responsible authorities, which supports our responsible authorities in planning, developing and using flood models for informing flood risk management decisions, and it was last updated in 2016. Both guidance documents are available at the links on the website, available on our website, and at the web addresses shown on the slide. Ahead of the release of the FEH updates in September, we're planning to prepare and distribute a position statement. This will be shared ahead of a wider, more substantive updates proposed for both our guidance documents later this financial year and into the next. Adam, could I have the next slide, please? So in terms of transition timeframes, our overall principles are very broadly similar to the Environment Agency's. So for new projects, whether that be flood risk assessments or flood studies, that begin after the updated methods are available, we would expect use of the latest methods and data. For those projects, again, flood risk assessments and flood studies that are underway and progressing through planning prior to the launch of the new methods, our preference would always be for the use of the latest methods and data sets. But for a period of up to 6 months after the new method datasets become available, there will be no expectation to update your existing calculations. However, and similar to the Environment Agency, any decision to continue to use the older methods in this period is one made by the project team and not ourselves, and hence the project team will retain the ownership of any risks associated with that choice of method, with their choice of method. There may also be circumstances where we will not be able to accept estimates using the older methods, and we'll provide further details of these in the full position statement that will be circulated in advance of the launch. After 6 months, we would expect to see the latest methods and data sets being used, or sensitivity to explain why this may not be the case. We also echo the Environment Agency's comments regarding using local data and checking catchment descriptors to future-proof submissions as much as possible. Thank you, Adam. Next slide.
Thanks, Becky. So finally, we've got, thirdly, we've got Owen Wilson from Natural Resources Wales.
Yeah, hi, I'm Owen Shepherd. I'm a flood hydrology specialist at Natural Resources Wales. So our flood estimation technical guidance, GN08, is currently only available on request through our sort of customer hub, although we are hoping that future versions will be made available online. So the latest version that we published back in December 2024 was an update to the 2021 version and included several changes, including some more recommendations around FEH 2022, some new software versions, non-stationarity, small catchments, as well as a number of other improvements. So in anticipation of the new catchment descriptors and FEH 25 statistical method, we made reference to this in our guidance, explaining that we would expect it to be published in 2025 alongside a new version of WinFAP. And to sort of try and sort of partially future-proof the guidance ahead of these updates, there's an extract there that we recommended that those analysts who would be applying the FEH statistical method should be using the latest version of WinFAP, albeit recognizing there's other software and formats that utilize this method, and those are also acceptable. But we do go on to explain that we may not necessarily approve submissions using older methods or data sets, and outline our sort of transition periods. So we are planning to update GN08 later this financial year to recommend use of the new descriptors in the FEH 2025 statistical updates. But at the present, we feel that our position is sort of adequately explained in the current version, so we're not intending to produce a separate position statement. It's also just worth noting that we do state in our guidance that the recommendation should be sort of used in conjunction with the most recent version of the Environment Agency guidelines and any flood hydrology research publications. Next slide, please. So similarly to the Environment Agency and SEPA, our guidance does allow for a transition period, albeit longer at 12 months. And we don't make any specific distinction between new projects and those underway. So our preference and recommendation would always be that the latest methods and data sets are used. However, we will accept submissions for review up to 12 months beyond the release of a new method or data set, without stipulating that those estimates must be updated. Beyond 12 months, again, we would expect the latest methods and data to be used unless there's been sensitivity analysis to demonstrate there'll be no significant change to the project outcomes. And similarly to what Claire and Becky have said, we support the recommendations about using local data and checking descriptors to future-proof the submissions as much as possible. Thank you.
All right, thanks. Just a quick check. Is there anyone from the Department for Infrastructure who wants to make any statement to this point? If not, I'm sure they will make their own position statement in due course. I think just some quick final remarks. As they've all just mentioned, UKCEH is a scientific institute. Always follow your local and national guidance and regulations. Don't just blindly follow what UKCEH says on this matter. Local knowledge should always supplement national scale statistics. So as they've all said, check your catchment descriptors, check if anything looks weird. Don't just blindly follow the equations as we've written them. There's full reports available on the FEH webpage, including a peak flows version 14 impact report. So similar to the study we published with peak flows version 13, there'll be a similar peak flows version 14 impacts report on our website. This and last week's webinars will both be on the YouTube channel. And I'd just like to give big thanks to all the regulators, the National River Flow Archive and Wallingford HydroSolutions, and everyone who's contributed to this work to get this over the line. It's been really appreciated, all the work that everyone's put in. So yeah, if you want to get hold of all of those details in full, there's a comprehensive report on our website, which you can get from that link. And you can email me at that email address. But for now, I think if I hand it back over to Will to kind of coordinate the questions.
Yep, brilliant. Thanks, Adam. Yeah, and thanks to all the speakers. Really, really, really useful. So we have less time than we did last week. Much more information packed. So what I'm going to do, there's been a huge amount of questions that have already been asked and answered by the speakers in the chat. So thanks for everyone for that. I'm not going to go through and read out the ones that have already been answered this week because frankly, we don't have time. And if you are interested, there's some really good questions in there, great answers. So do have a read through the chat so that you don't miss out on anything. There are still some unanswered questions, so I will go through those and relay them to you guys. So the first one, I believe, is Richard Cartledge. Over the past 20 years, new urban areas will have increasingly been subject to surface water runoff attenuation via use of SUDs discharging at greenfield runoff rates and increasingly at QBAR rates. Has this been or should have been considered when updating the urban adjustment factors? Oh, I apologise. That's actually already been answered by Tracy. These answers.
I should say I didn't answer it very well. So if anyone's got a better answer, please chip in.
Yeah, I think the response, which is we just don't have the sufficient amount of gauge records to properly capture it yet. It's obviously something we'd love to look into, but we don't have the data to properly make any specific recommendations.
Brilliant. So there's a question here from David Cameron. For SEPA, will the transition also include FEH rainfall runoff to RefH2?
Hi, thanks, Will. I've actually answered it in the chat, but it's absolutely fine. Just to say, it's something we'll consider and it'll be assessed when we do the more substantive guidance updates. So thanks.
Okay, perfect. Thank you. All right, third time's the charm. I don't think this one's been answered yet. This is from Eleanor. So what about where there's a very major planning application, over 1,000 homes, that is at the outline stage now, and at later planning stages, FEH 25 will be released. Should the LLFA be okay to push FEH 25 in drainage strategy?
I could come in on this potentially and say that it's up to individual local flood authorities to determine their own policies with regards to what they require for SUDs and drainage strategy. That's not within the Environment Agency's remit to do that. But I would note that there has been non-statutory guidance for design of SUDs recently released on gov.uk that we would recommend everyone take a look at. And local flood authorities may be updating their policies right now with regards to that anyway. Thanks.
Brilliant. Thanks, Claire. Another question here. Is it possible to provide a GIS shapefile or equivalent spatial data set, including both QMED 100-year of 2025 method and 2008 method used for the comparison plots?
We'll have a look into that. There'll probably be quite a lot of data that'll be available through the NRFA API as things get updated. So some of those catchment descriptors and some of that data will be available in that. You can look at the NRFA stations for that. Yeah, I'll look into seeing what the feasibility is for any sort of data set to accompany a report.
Brilliant. Thanks, Adam. And another question, what is the proportion of the small catchments in this update?
I can get the number right now.
Ah.
I just got R open specifically for this purpose. We'll do length there. There's 128 catchments smaller than 40 square kilometers out of 884.
There you go.
So that's 14.5% of the data set.
Brilliant. Thanks, Johnny. So that's all the questions I can see. Kirsty, have I missed any questions or any other?
Not that I can see. I think you've covered them all. Yeah.
Okay, perfect. Thanks. Brilliant. Okay, so were there any other finishing pieces of information that any of the speakers would like to add? Oh, sorry, I will cut myself across that. There was a new question. What is the minimum catchment size for which 5.3 is considered suitable?
Just give me one. The smallest catchment in the calibration data set is 1.63 square kilometers.
I think I would just add that the smaller the catchment, probably the higher the uncertainty is what we generally see. So yes, but there are sort of no other methods really to calculate it in small catchments. So you just have to bear that in mind when you're completing it.
Okay, brilliant. And there's one last question here. Why the threshold of 42 kilometers squared? I think there was a threshold you pulled out of R there, Gianni.
So that was it's a threshold of 40 square kilometers, and that was the threshold used in the small catchment study to define small catchments. So the limit of the small catchments methods as did exist in the current FEH statistical method.
Brilliant.
Yeah.
Thanks for that. Okay, well, I think that seems like the end of the question. So sorry, I will go back to my previous question to the speakers just to make sure there's no final comments or pieces of information you'd like to get across.
No, just if anyone does have any further questions they think of, especially if you have a chance to read the reports in full, do get in touch. If you know the appropriate email address for your national regulator, then feel free to get in touch with the regulator directly. If you have no idea, then I might be able to pass on some questions to the regulators.
Okay, brilliant. Thanks for that, Adam. And yeah, thanks to all the speakers. Thanks for everyone for dialing in to this. As I said, the webinar will be available on the British Hydrological Society YouTube channel shortly. Yes, thank you very much for joining and enjoy the rest of your day.